Hi, we are team Drop Database MyUNSW, and the member of these teams are me, Albert, and then Anton, Hang or Kurt, and then Pirawich or PJ. We are going to walk you through how we have built our assignment 2 of comp9321 2015 semester 2. The assignment was to build an e-commerce site for books or publications or papers, complete with login functionality, search, buy and sell features, admin user account with full control, and activity logging. These are all the things that we will go through our video. So firstly, overview of our architecture, and then deeper explanation of each of the MVC layer. So there'll be model layer, controller, and then view layer. And then we will do a demo for three most important features. And then the last one will be discussion around further possible improvements. We just wanted to say that we learned so many valuable things from doing this project, and we also hope you can learn something new and useful from watching this video. So, application art structure. Our application uses a three-layer architecture where we have the presentation layer, business layer, and data access layer. Through our demo, we will show that we have a really clear separation between these three tiers, and they map perfectly to the MVC paradigm, M being model, V being view, and C being the controllers. Just an overview. Our stack uses MySQL as the database, Java servlets with Tomcat as the backend, and React.js for most of our frontend code. We picked MySQL because it's one of the most popular RDBMS, and therefore we can safely assume it is reliable and stable. Java servlets is one of the most popular ways to build web apps, especially in enterprise setting. It is very fast, efficient, easy to learn, and there's a big community that is driving its development. And lastly, we chose React.js as our front-end code because we can provide better UI and experience through JavaScript. And as we will show later as well, React makes it possible to create decoupled UI components, which has dramatically increased our front-end code reuse. Another thing to note is that we really take the search feature seriously and have implemented a good search engine for system to scale. We will also talk about this more later. Lastly, we structured our backend so that most of the app's interaction go through a REST-like API where data exchange is done through HTTP requests with JSON responses. This means that adding another client, such as a mobile app, is easy because the client, or the view layer, is completely decoupled from data access. This is also another reason we go with React, as it makes it easy to do front-end logic and operations such as AJAX. An example of a GET operation in our application runs through this process. First, the React component fetches data from an API. We do this using jQuery AJAX with HTTP GET. And then the API routes the request to the requested controller. The controller will fetches data from DAO, our data access object, and then the DAO will queries the database and forms the response in Java objects, and then the controller will send back the response packaged in a JSON format to the client. An example of a post request will be very similar. So it starts with the React component doing a post request to the API, which again delegates the controller, which will then validates the given data and submits to the DAO. And the DAO will perform a database operation, and then it will send back the response to a controller, which will then convert the JSON and then sends back to the client. Next, we are going to walk you through our code and app, starting with the model layer, and then controller, and then view layer, so from bottom up. We'll also have a few examples features on how all of these layers play well together. Firstly, the data store. So the first layer is the database storage, which is, in our case, is a MySQL database. The database schema is simple and store information about all users in the system and registered publications. User activities represent the modifications to a user's shopping cart, that is, adding, removing, or buying publications. We separate buyers, or customers, and sellers with a field name role, which holds a string of the respective type. And then we're going to the data access layer. The package containing Java models of the database has a structure very similar to the tables in our database. There are a few extra classes that helps us group sets of publications or activities together. One of those is shopping cart. And then we move on to DAO, which is our data access object. The data access object is an interface that provides all functions you are allowed to perform against the database in the system. This means that all communication to the database goes through this interface. The DTO we saw on our last slide are used as return values and parameters in this interface. So we're going to go through our implementation on converting to DTO. The implementation class of DAO is one of which creates database queries and statements. It then converts the result from the database calls to DTOs. We see in this example how it works. The first method returns random publication to the controller. It then takes a parameter, determining the maximum amount of publication it should return. We define the SQL query and pass it to a helper function, used by all of DAO's method, returning a list of publications. This helper method creates a prepared statement and puts the parameter as the single argument for the query. Prepared statements helps us prevent SQL injections. The result set now contains a cursor that we can move to each of the rows. The cursor works similar to an iterator in Java. On the next slide, we will see how we convert one row, a cursor point, to a DDO object. As we see, the conversion is very simple. From the result set, you can fetch data of different types by passing the database column name. Next, we are going to talk about the business logic layer, or this is where the C is in MVC, the controller. So our control layer consists of a lot of files, and we have a lot of controller files. This includes the admin, auth, customer, publications, search, seller, and user controller. And all of these deals with different things and have different responsibilities around the stack. Say for example, auth controller deals mainly with user login and logout, and publication controller deals with listing 10 books or journals publications when asked by the API. And governing all of these controllers, we have two main servlets. These servlets are the API controller servlet and web app controller servlet, and they have very different responsibility. The web app controller servlet mainly serves requests when the client requests for HTML document, and within that HTML document we actually have our React component that when rendered on the client will fetch data through our API controller servlet so that they have enough data to render meaningful dynamic content to the user. So a lot of our data is actually accessed through the API controller servlet, which means they are accessed by normal HTTP requests, which can be either get, post, put, or delete, just like in a normal REST protocol. And then control objects uses DTO or data transfer object to interact with database, just as we talk about in the model layer discussion. And then when results are obtained from the DAOs or controllers or DTOs, the results are transformed into JSON objects that can be sent back to the client in HTTP response. This is our main code in the API controller servlet. Our servlet for the API is basically just a router configuration which delegates all requests to the controller that is responsible for that specified request. It also takes the return value from the controller actions and prints it as JSON to the output. Exceptions, such as authentication problems, are catched by this class and presented to the user in JSON as well. The following examples shows a simple implementation of a controller action that the servlet delegates to. This method calls the DAO function that we previously looked at and returns the result to the servlet. So, how can the API be used? It is just a normal HTTP GET, POST, PUT, or DELETE request that returns data formatted in JSON. Here are the first two publications returned by the controller action we just looked at. And you see how we in the URL can pass parameters to the servlet and controllers. Next, we are going to talk about our presentation layer or the view layer. As we have said earlier, we use React for the front end of our application. React is an open source JavaScript library created by Facebook for building user interfaces. React makes it easy to automatically re-render views when data is in change. It does it automatically actually, so we don't have to do anything. The renderer is smart and does not re-render a view if nothing has changed. This is really good for a performance aspect, since changes in HTML DOM can be very expensive. Views in React are built from components. A component is a JavaScript object that can contain some properties, and it defines how it should be rendered by a browser. The language you define how to render is called JSX, which is like a combination between JavaScript and XML. Once a component is created, it can be used wherever you want and how many times you want. Therefore, React can be very modular. In the example here, you see a simple React component. The component is created at the bottom with an attribute called name. These attributes are called properties, and these properties can be retrieved by calling this.props, as you can see in the render function. A React component has some functions that are automatically called when it is created, added to the DOM, or removed from the DOM, etc. These are called lifecycle functions, and you see some of them here. On the last slide, we saw how properties could be passed to a component. Properties can be changed from inside of a component. However, changeable variables that we want to store in a component can be stored in its state. The initial value for the state is returned by the function getInitialState, which is called before the component is mounted to DOM. The state can be rendered exactly as the properties were, but by calling this.state. We can change the state by setting Set state. This is what we do for setting the data we really want to show to the user. Here we fetch an array of elements from the API when the component is mounted. This is a very common thing to do in the component did mount lifecycle callback. When setState is called and any of the variables in state have changed, the component is re-rendered by getting the render function again. How do we use React from JSP or from HTML? We just include the React library file and the React component files we have created, and in this case it's only one. Then you call React DOM.render on your main component and specify the HTML DOM object where you want it to be mounted. Your main component can then include all your other React components you want to render. Now, we are going to start talking about demoing our user accounts and login features. Firstly, we will go through how the user can interact with the web app, and then we go to the code. When we're going to the code, we're going with the order of first view layer, and then control layer, and then the model layer. We believe that this will simulate how the app works in real time, because requests will start at the client and goes to the server and goes back to the client. Okay, so this is the first page when a user will see when they hit our app. As you can see, right up there, there's a button called sign in or sign up. When clicking this button, you'll be presented with a pop-up box that you can use to sign in or create an account or sign up for the first time. We're going to sign in for now. Firstly, I will try to use the wrong password. Right. This will let you see that um, the app handles errors by showing error messages to the client. Now, I'm gonna log in with the correct password, and this should log the user successfully into the app. Now, as you can see, once the user is logged in, you can see there is a shopping cart and your customer tab, and here you can go to account settings. This is the page where you can change all your details except your user account. Okay, now we are going to see the code. This is accounts UI.js, which is um, the React component for that pop-up box where you can sign up and sign in. It has got a few smaller components that is used by this UI component. As you can also see, that the accounts UI component does a HTTP post request to our server via Ajax. The first one is used for sign up, and the second one is used for password reset, and this one is used for login. Once the Ajax has been sent, uh, API controls sublet will be called, and depending on what the URL was called, the API controller will invoke either search controller or customer controller or user controller. So it depends. Say if a user wants to list 10 publications, the new publication controller will be invoked. Right now, since we are just logging in, we were using post request with the URL of login, and this is controller by the auth controller, which handles everything that has got to do with login and logout. Now, looking at auth controller, you can see that we have the login method that was used, and the login method itself uses the DAO and the DTO. Now, this DAO and the DTO are our model layer, and they're the one that is computed and gives us the result that we want. This result will then be returned to the API controller server. And as you can see here, we have this class called API response writer. This API response writer basically takes a result and package it in a JSON format and then sends it back to the client so that the React component can see it and then render the new data to the user. So this is how generally our API works and how the login works. Next, we're going to talk about our advanced search feature. So here we're going to the home page again, and then say we want to search for, let's say, software. This is, by the way, the search bar at the top of the bar out there is simple search, and once you do simple search, you get to a page here where you can do an advanced search. Advanced search lets you search by title, authors, venues, year, and you can filter by year, price as well, and then the types, whether it's books, conference, or publication journals. You can also add words that you don't want to appear in the search using this exclude. Say we are looking for software and the other name contains say, I guess, and the price must be above $20 and maximum $9.99. Yep. Hopefully this returns a few. So we have 36 items found in our database, and here's our first page, and we have also implemented paging. So you can go next, and we'll go to the second page. Yep, still 36 items found, but this is the next page. Every page views 10 items. You can see each publication or book will have title, the type, authors, publisher, and year. Yes? So now we are going to go to the code. The advanced search feature is implemented by this advanced search React component. It has only a few smaller components, which are the advanced search form and the result box. The result box actually contains listings, publication listing, and this is the same listing that we use in our publication file here, publication.js. This is where React.js modularity comes in really well to help us with code reuse. So when the user submits an advanced search, it will do a an HTTP GET request to our API endpoint here. And this request, of course, will go to the API control servlet again. Now it's time GET, and it will hit this search/advanced URL. It will be handled by the search controller, and the search controller that will be called is the advanced search function. See that we get all the parameters. It's quite big because we have exclusions and filtered by year and prices. We make sure every value is valid. And then again, we use the DAO to work out and to get the results that you want to present to the user. And then the DAO, result from the DAO, will be again returned to our API control servlet, which will then send the result to API response writer, which will package the result as a JSON object and sends it back to the client. The advanced search feature is all, the processing is all done in this method. This is all the parameter validation. And as you can see here, the DAO actually is the one doing the fetching data from the database. It not only fetches data, but also looks for a randomized one and make sure it returns a value that satisfies all of these input parameters. I just want to show that method there. The get publication advanced search. That is simple search. Even simple search is quite long already. This is get publication by advanced search. As you can see, these are the processing that we do to get the desired result. We use regex, we use a lot of ands and ors, and yeah, this is where the power of our search engine comes from. Lastly, we are going to talk about our admin account demo. And for this demo, we won't be spending so much time on explaining to you how the demo features work for the user, but we will be spending more time explaining the code because I'm sure by now you'll get more understanding on how the UI works and how it deals with the API. Now, for the code, same as before, a lot of work is done by the API controller servlet and web app controller servlet. See here, for example, in the API controller servlet, for the get server, you can see a lot of admin methods that can be called by the client. And all of them, almost all of them actually, are controlled by the admin controller here. This admin controller is actually the controller object that handles everything related to an admin account operation. Say for example if they want to remove publication from the listing or get all customer data, get all publication data, ban and unban a user. We separate this from normal user because of course it's obvious that admin has a different permission level from user. So just for security purposes, we make admin as a totally different object and a different model. But same as before, admin control still uses DAO and DTOs to make sure that it fulfills requests and then gets data from the database. And then same as also before. The result is sent to API response writer, which will package the response to a JSON object, and then it will be sent back to the client. Lastly, we want to talk about possible future improvements that can be done to our web application. We will talk starting from the view and then controller layer and then the model layer. Firstly, this is our first time learning React and using React in a project, us together as a team. Therefore, we don't know the best practices yet. We've really understood that it lets us write very modularized front-end code, but that we still have a few components that we think can be separated out and decoupled. So for further future projects, we sure can make better React components that are more decoupled and more modularized to better help with our code reuse. And then we can also use React Router, which is a project that helps projects that use React as their own, as the sole front-end framework. Because React is different from maybe Angular JS where it has a client-side router. If, if you notice in our code, we have a very simple router, but it's a bit flawed where if you say go to the shopping cart and you refresh the page, it refreshes back to the home page, not the shopping cart, because our router that we make doesn't save your state somewhere. It just saves it in your current session in the client side. And then next, we might be using the flux paradigm introduced by Facebook to be used with React. This is very useful when the React project gets really, really large, where it has one centralized store, or components can listen to events that comes out from the store. So like it can manage a lot of React components at the same time. And then moving to the controller layer, we would also like to make the DAO more modularized. Maybe you have seen this from our code, but our DAO implementation class is a one big file, and sometimes working on a few smaller files can be easier. It might also be a good idea to separate, say, login, logout functions and buy and sell functions into different files. And then we're also thinking to make the API more fitting to conventional REST standard, because the way we use our current URL scheme is not exactly REST standard. This is just for further improvements down the line if we want to create another client-side app like a mobile app so that it's more standardized. And then maybe you have realized that we don't use a database connection pool. We actually have been testing to just use one connection for the whole life of the server, or we connect and disconnect for every request, but we never tried using connection pool. Actually, this is, we think, the best way to do it, actually, the connection pool, but we just haven't tried it, and we think this is a possible future improvement for sure. I think that's all from us. Thanks for watching. I hope you guys can learn something from this video. Thank you.